Hi, everybody. Welcome back to Dave's Math Channel. And this is my second video on my new feature on the Math Lovers book. Like I mentioned in my last video, this is a 3-volume series, and these are pictures of each of the 3 volumes. And if you're interested, you can buy these. You can buy any one or all three or any combination on Amazon.com. Just look for either look for the Math Lovers book, or you can look for my name, David Tear, and you'll find these books there. And they're, I believe, $30 each in paperback and $9 on Kindle. I think they're a good buy. Just thought I'd mention that. And like I said, this is my second video in my series. I'm doing free videos, video lectures on. I'm going to try to get through all well, at least the first 2 volumes. The third volume is problems and solutions. But anyway, and I think I should probably say a little bit about the first 2 volumes. The first volume is mainly recreational math, kind of high school level recreational math. The second volume is a little bit more advanced. It's undergraduate level, and it's more like a textbook. It has more kind of academic um, concepts. And anyway, let's begin with today's video. So today I'm going to talk about face valued number systems. And most of the most ancient number systems that were used were all face values. There's two types of number systems. There's what are called face valued number systems. Those are numbers where each symbol in the number is represents a different number. For instance, Roman numerals. There's 7 different symbols for Roman numerals. I'll get that later, but they represent 1, 5, 10, 50, 100, 500, 1,000, as I think you guys all know. But the modern system we use, the Hindu-Arabic number system that uses the decimal digits 0 through 9, that's an example of what's called a place value system. So, for instance, there's the ones place, the tens place, the hundreds place, thousands place. It turns out to be a much more useful number system. So, I think it was a big evolution going from face value to place value. But we didn't really have place value numbers, at least in the West, we didn't till around 1200 AD. It was Fibonacci who introduced the Hindu-Arabic number system to the West, but it had already been invented, I believe, in various forms around 1 AD. I think the Mayans were the first to use it, and then I think it was in the Persia around the 6th or 7th century, and then finally India around the 10th century, something like that. But anyway, let's just begin today's lesson. So, like I said, I'm going to talk about number systems. I already described them in detail, so I won't go through this slide again. But anyway, so the first known place valued number system was the Egyptian numerals. And I think I should mention before I even do this, there were other number systems that were used that were even more primitive. I don't talk about in my book, but there's a famous artifact known as the Shango bone that was found in I believe it was Nigeria, and it dates back from around to about 20,000 BC. And this had little tally marks on it. And most archaeologists think that these were the first numbers that were ever used. They don't know what they were used for, but pretty clear they were numbers, and they were just tally marks. But then after we had tally marks, we had face value number systems, and the first known one was Egyptian numerals, and there were 7 symbols for powers of 10. One was just a straight vertical line. 10 was a horseshoe symbol. 100 was a little kind of coiled up rope, I guess. 1,000 was an arrow. 10,000 was a finger. 100,000 was a tadpole, and 1,000,000 was, this is supposed to be, I guess, a Egyptian god praying to infinity, because 1,000,000 was the biggest number they could imagine, basically. But you could combine these numbers and come up with arbitrary counting numbers or natural numbers as you like, if you like. For instance, you would write 276 as shown on the bottom left. 200s would be 2 coils. Uh, and 70 would be 7 horseshoes, and 6 would be 6 vertical lines. So that picture on the left represents the number 276. And the order in which you draw the symbols doesn't really matter, but it was traditional to start with the biggest symbols and go down from that. And then there's just another example on the right, 4,622. This has 4 arrows. Each one of those is 1,000, so that's 4,000. Then there's 6 coiled ropes, so that's 600. And then there's 2 horseshoes. And notice we are drawing the horseshoes to the right here. We could have drawn them to the left, but they're on the bottom line, so that's 20. And then there's 2 vertical lines representing 2. So that's the number 4,622. And if you look at Egyptian hieroglyphs, you will see numbers represented this way. So, and then the Egyptians actually did a little better than this. They also came up with fractions. There are fractions called Egyptian fractions, and they didn't represent arbitrary rational numbers. They only represented fractions with a numerator of either 1 or 2. And the way they would indicate a fraction is they would start with this I symbol. And the I would tell you that the remainder of the number goes in the denominator. So a single I would represent a numerator of 1. Sometimes they drew 2 I's representing a numerator of 2, but they didn't go beyond numerators of 2. So working with fractions was kind of cumbersome with Egyptian fractions. And actually, it turns out you can write every rational number as a sum of Egyptian fractions. You might have to use an arbitrary number, but you can always do it with a sum. So anyway, so these examples I show, the first one is 1/3 because you got the I symbol indicating it's a fraction with the numerator 1, and then you got 3 vertical lines representing the denominator of 3. And the second one, you have the I symbol again, meaning it's a fraction with numerator 1. And then this time there's 5 vertical lines, so that represents 1/5. Finally, the last one, again, you have the I symbol, this time on the upper right corner. It doesn't really matter where you put it. And then the remaining symbols represent the number 249, 2 coils, 4 horseshoes, and 9 vertical lines. So that's number 249. So this is a fraction, it's 1 over 249. So that's Egyptian numbers and Egyptian fractions. And actually, there was another Egyptian numeral system that came later. And these are called hieratic. This was a little bit more sophisticated system. You could represent bigger numbers this way more compactly. And we'll see that there's other number systems that are very similar to this that came later. So the first Egyptian numbers, I think, were invented around 3000 BC, right around the beginning of the Egyptian civilization. But then hieratic numbers came later. This was after the invention of papyrus in Egypt around 1800 BC. So they would write these hieratic numbers on papyrus scrolls, I guess, and it was just a more compact way of representing numbers. And we have these weird symbols. There's 36 of these altogether. They represent the numbers. So there's 9 of them represent the numbers 1 through 9 in the leftmost column, first column. Second column is the numbers 10 through 90. Third column is the symbols for the numbers 100 through 900. And then the fourth column is the symbols for numbers 1000 and 9000. By combining these symbols, you could represent arbitrary numbers up to 9,999. So that was a pretty robust system. And just to give you a couple examples here, here's a couple ways we could write the number 2,765. Like I said before, the order of the symbols doesn't matter. So the one on the left shows the symbols going from right to left, I believe. Let me just check that. Yeah, no, actually, it's from left to right. Yeah. So the first symbol here is the symbol for 2,000. Second symbol is the symbol for 700. You can check that on this table. So third number is a symbol for 60, and the fourth symbol is a symbol for 5. So on the left, it shows them going from left to right, and on the right, it shows them going from right to left. You could do it either way. I think I could even mix up the order, but I don't think the Egyptians did that. But anyway, those are 2 ways you can represent the number 2,765. And I think this face value system the Egyptians came up with actually led to several other similar systems in other cultures. For instance, Hebrew numerals. There's, I think, with these Sophid symbols, there's a total of 27 Hebrew letters in the Hebrew alphabet that are still used today in Hebrew. And I think there's even some Hebrew mystics or religious people, maybe Orthodox Jews, who still use this number system. They use it to interpret, I guess, words in Hebrew and words in the Bible. I think even the Bible code, which I think is a bunch of bullshit. But I think the Bible code actually does use these values for Hebrew numerals. So you can represent every word in the Bible as a Hebrew numeral, and you can come up with whatever kind of religious or mystical interpretation you want, including the end of the world, which I think a lot of people done, but I don't believe this stuff. And just to say one more thing about this, the reason I don't believe it, I watched documentaries on this, and people have done the same thing with Moby Dick. I mean, there are a lot of sticklers, religious sticklers who think that there really is a Bible code and you could even use it to predict future events. But it's really just looking for what you want to see, because this has been done with Moby Dick. I watched a documentary once, and people did the exact same thing with Herman Melville's Moby Dick. They claim that they could predict, and they only predict events that have already happened. That's their evidence, because we don't know what's going to happen in the future yet. But as far as I know, nobody's ever predicted any future events using any kind of numerology involving the Bible. And if you could do it, you could probably do it with Moby Dick as well. So I just thought I'd mention that. I'm not a numerologist, and I'm not religious in the traditional sense. And I just think this got a lot of hogwash. There was a movie that came out, I think about maybe 20 years ago. It was called Pi, where I think the main character in the movie actually does figure out a Bible code based on a computer glitch. But that's very very far fetched sci-fi in my opinion. And even Wall Street was interesting because he thought he could predict the stock market with it. Bunch of baloney in my opinion. You can't predict the future using any kind of numerals. But anyway, enough of that. So the Hebrew numerals, I digressed quite a bit here. But the Hebrew numerals are very similar, as you can see, to the hieratic numerals. It's just that these only go up to 900. So there's only 27 symbols, which only allows you to go from 1 to 900. But by combining them, you can play the same trick. You can represent every number from 1 to 999 using combinations of these letters. And you only need to use 3 of them, whereas you need to use 4 for hieratic. But then again, you don't count as high. And then Greek numerals are also similar. And Greek are more like the hieratic. These were ancient Greeks. I don't think the Greeks do this anymore. I'm not sure if they do. Maybe I'm wrong. I don't know. But Greeks could go up to 9,999 using the letters in the Greek alphabet plus some variations of them. I think there's only 24 letters in the Greek alphabet, but there's alternative ways you can represent a lot of them. And altogether here we got 36 symbols, allowing us to do numbers from 1 to 9,999. And then finally, I think you guys all know about Roman numerals. We still see them today, not as often as we used to, but Roman numerals are still used in various contexts. I think, forewords of books, they usually number the pages in Roman numerals. Also, there's still, I think, some old clocks where the numbers on the face are Roman numerals. You see them every now and then. Some people like to, title the sections. I even do it in this book. I titled the sections of my book using Roman numerals. But I don't really like Roman numerals that much. They're a pain in the ass to work with. They're not convenient. One thing I think I need to mention, I think I already did mention this. Face value number systems are not convenient for doing arithmetic. They're a pain in the ass. You can do arithmetic, but it's much, much harder with face value numbers than it is with place value numbers. That's why place value was such a big advance. And I think I just want to say one more thing. Like I said, I think most of you guys are familiar with Roman numerals. There's 7 symbols again. They use Roman letters, capital Roman letters. I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1,000. I may as well tell you guys a joke. I just came up with this joke about a month or 2 ago. So X is a symbol for 10. And I don't know if you guys know what about decimation. the ancient Romans were a pretty brutal society. They used to decimate criminals, meaning they would kill every 10th one in line. I think even Josephus faced this problem. But I came up with a funny joke. At least I think it's funny. I said the Romans decimated their X's because X is a symbol for 10. So I thought that was kind of funny. And maybe they did. I don't know. Like I said, they were pretty brutal. They also involved themselves, at least in the nobility, the emperor and the congressmen and all that. They had these big orgies. They had dozens of girlfriends, and they may have decimated every one of them that they didn't like. I don't know. But anyway, that's Roman numerals. And that completes my video for today. So thank you for watching. Long live math, and I'll see you guys next time. Bye.